Yo, what's up, everyone? My name's Dave, and you suck at programming. Today, we're going to demystify heredocs, specifically in Bash. I think other shells have this too. But have you ever seen syntax like this? You know, when you run a command like cat, or you look in a script that has this, and you'll see one less than sign. Okay, we're going to read in from a file. That's great. But then you see two less than signs, and maybe EOF or some string like that, or two less than signs, and then a hyphen, and then EOF. Or sometimes there's EOF, and it's in quotes, and you're like, okay, I know something's going on here. What's going on? That is called a heredoc. This is the word I'm saying. Heredoc is what they are called. So yeah, let's jump into it. We have a bunch of scripts here. Let's jump into the first one here, simple. So here is the most simple example of a heredoc. Take a look. We have cat. Cat reads in less than until EOF, and then we have EOF right here. So what's happening? Bash has this notation of less than, and then you give it a marker string EOF here, and whatever text is here will get passed to cat over its standard input. And cat, very simple program, reads in from standard in and writes the standard out. So if all things work as we expect, this should show up on our terminal. Hey, look at that. That's super simple, works exactly how we want it to. In this example, we have a couple spaces at the beginning. Those spaces are retained. Hey, that's amazing. Let's look at our next example called indent. Can you see where I'm going with this? Let's say we have a function. We have a function here called main, and we have cat in here, EOF. We have hello world with that indentation. And then notice EOF shows up here. If I put it over here, fails, doesn't work. It has to be on the beginning of the line, okay? So let's go ahead and run this example. Look at that. Now it's moved over by a whole tab character because I indented it with tabs. So it retains the white space even when you're in multiple levels of indentation. So is there anything we can do to fix that indentation? Well, let's take a look at fix indent and see. Hey, look at this. We have the exact same syntax, but you see this character right here that I'm hovering over? The hyphen, that's what that does. So we have less than hyphen. Hyphen just tells it to ignore the leading indentation. So it's super useful. We can put it in little functions like this. And notice it still retains the spaces. It just got rid of those tab characters there. So it's pretty smart when it comes to that. You can get into some weird situations with it. But yeah, this is super useful. We can also put EOF at the same level of indentation as our cat invocation, which is super nice. We don't have to put it at the beginning of the line. So that's super nice. Great for like usage messages if you're inside a function or whatever. Let's take a look at this next example called variables. We set foo equal to 1 here, and then we run cat. We're using the hyphen, though it doesn't matter. We're not at any sort of level of indentation. And in here, we say hello $user. This is all capital. This is built into Bash. This should resolve to the current executing user's name. Foo is $foo. The uname command says uname. Look at that. We're using command substitution in here. So what do you think is going to happen? The syntax highlighting is kind of giving it away, but let's take a look. We run this, and it all works how we expect it. Hello, Dave. Foo is 1. The uname command says Darwin. Hey, that's awesome. That lines up with what I would expect to happen there. So what about this next example called no variables? What's going on here? It's the exact same code, but look at this. We have quotes around EOF. EOF is quoted. Notice down here, the quotes are gone. The quotes are special. The quotes say whatever goes in this heredoc is literal. Don't try to do any sort of processing on it at all. So we have $user there, $foo. We have the command substitution. Let's go ahead and run this, and we get the literal string. So quoting the EOF marker in heredocs will make it so it doesn't undergo variable expansion, all sorts of like splitting, stuff like that. So in our next example, we have something called any EOF. What does that mean? Look at this. We changed EOF for anything underbar LOL. It can really be anything. There's some weird exceptions to this, but for the most part, it can be anything. So we run this example. I'm not tricking you. It works exactly how we think it should work. Hey, that's pretty cool. Example number 6 here, we have not just cat. You can use other commands. We're using cat because it's a very simple command, but you could use grep, you could use whatever you want. In this example, we have echo. And let's look at this example. We echo foo. Foo also reads in from standard in and says bar. Cool, right? Let's go ahead and run that. Let me type the right thing. Okay, there we go. And all we get is foo. We don't get bar. When I said echo reads in from standard in, I was actually lying. Echo does not read from standard in. It's being passed this over standard in, but echo does not look at standard in. Echo takes arguments and echoes them. It does not read standard in. Cat reads from standard in. A bunch of programs do. Echo does not. So that bar is lost. That bar is completely gone. We don't see it anywhere. So in our next example, you can pipe this. My syntax highlighter doesn't like it, but it works. We're going to cat whatever comes in here. Cat's going to pipe this to NL, which will give it line numbers. We're going to grep for the word bar, which should match because it's right there. And then we're going to pipe it to tal, which again won't really do much. This is just to show that the pipeline will work how we expect it. And there we go. We can see the first line was bar. We could prove this. We could do foo, bar, baz. So because we're grepping for bar, it should find the second line. So that number should change from 1 to 2. And there we go. Hey, it works how we expect it to. The last example I have right here is called Who Wins. So here's an interesting example. Echo foo, pipe it into cat. So cat should print foo, right? Well, we also have a heredoc here. Cat's going to read bar on its standard input, but we're also passing foo over standard in. We can't have two standard inputs, so what's going to happen here? What's going to print? Are we going to get foo? Are we going to get bar? Are we going to get a weird combination of the two? Are we going to get yelled at? Let's find out. The answer's super underwhelming. It's just bar. So let me, here, I'll pull up both so you can see both at the same time. As you can see, the heredoc won. The echo foo here, that was lost. That's completely gone. The heredoc won. That is just how bash works. In fact, if you were to use a tool like shell check, which will do static analysis of your scripts, you can see that it even yells at you. Look at this. This redirection overrides piped input to use both merge or pass file names. So it even says this redirection overrides piped input. So that's what's going on there. Can't do anything about that. And yeah, this has been a crash course in Heredocs and Bash. Yo, and as always, I want to give a quick shout out to my patrons over at Patreon. Thank you for your continued support. That's awesome. If you want your name at the end of one of my videos, go ahead and check out my Patreon. You can see the link right there. I'm going to read them out, but I can't guarantee I'm going to keep reading them out in the future because there's a lot here. And I'm getting some comments from people saying like, this is kind of a waste at the end of the video. People in my Patreon are like, you know, you don't need to actually read my name out. So we'll see how long I keep this up. No guarantee I'll keep this up going forward. But for now, shout out to Bubsky, thank you Jeffrey, Balram, Wild Trudeau Coffee, Gustavo, Nick, Vasily, Fractal, Hawk, Nameless Beard, Vorno, Arex, Aaron, David, Ron, Adam, wow. Thank you Arex, Aaron, David, Ron, Adam, Greg, Tiago, Alex, Hayden. I'm sure I mispronounced some names there, but thank you so much. Appreciate the continued support, and yeah, have a good one.